is like that. First, we are going to see about just a minute. First, we are going to see about what exactly the meaning of smart contract. Okay, number one. And then we will see that if you want to build up your smart contract for your application, then what are the different tools available to develop the smart contract? Number two. Number three, we will see that how this Ethereum Remix ID, okay, which is going to be a kind of a platform used by across the globe for development of smart contract, for writing the smart contract. And in this particular session, we are more focusing towards the implementation part, okay? Because in smart contract, implementation plays a very, very important role, that how you are going to write your smart contract, what kind of platform you are going to use to write the smart contract, how you are going to compile your smart contract, how you are going to deploy your smart contract, and how the cost related to the smart contract is debited from your MetaMask account. So this aspect we are going to see. So in the next 30 to 40 minutes, we will see the theoretical perspective of smart contract, what exactly the meaning of smart contract and how it is different from the traditional contract. So now, first we will see what is Ethereum. So if you just Google it, then you will find that now the community is more supporting this Ethereum platform. Why? The reason is very simple, because it is an open source platform which will give you some kind of features where you if you want to write your smart contract, then you can write easily your smart contract. So now from where this smart contract comes into the picture? So this smart contract term is not a new term, okay? So over the inception of this blockchain technology, this smart contract terms comes into the picture, and now it is going to be a kind of a booming word, I can say. Why? Because in the industry, a lot of demand available for, like in the one time there is a era of J2EE developer. So similarly, in the times to come, in the next 5 years, in the times to come, there is a demand, high demand of blockchain developer, and among the industries who can write the smart contract for the different applications under the defined scenarios. So now coming back to our discussion, that what exactly this smart contract was coined by Nick Szabo in 1994. But I have already told you that with the inception of this blockchain technology, distributed ledger technology, this is now booming. The reason is very simple. In 1994, when Nick developed the smart contract, then he already finalized or already claimed that if anyone want to realize the actual outcome of the smart contract, then this can be possible with the help of a ledger. Okay, at that particular instant of time, he has already claimed that a ledger is required if you want to visualize the entire impact of the smart contract. So now, how exactly the smart contract works, and with the considering some realistic application, we will discuss that how it is different from the traditional contract. So now let's say your digital currency is just one application on the top of blockchain, because it is just like that you are having your two-wheeler or your four-wheeler available with you, and you cannot drive, you don't know how to drive this two-wheeler or four-wheeler, and particularly for the four-wheeler, then you have to hire the driver, okay? So similar to that, we can say blockchain is going to be kind of a platform, and over that particular platform, you can develop, or you can use, you can implement multiple applications like cryptocurrencies, various cryptocurrencies, or applications like if you want to use the blockchain in the government services. Now, coming back to our discussion, that let's say for a particular application, if I say that there are certain number of users, or you can consider them as a stakeholders. So in any of the application, if we are having multiple stakeholders, and the objective of these stakeholders are they want to do some kind of buying and selling, or they want to do some kind of credit and debit of what, of some money, whether this money is going to be kind of a digital money or going to be kind of a digital currency, you can say simply. Now, how this decentralized consensus comes into the picture, that we have already seen in our previous session, that proof of work, proof of stake, proof of burn, or proof of last time. Now, let's say in this particular ledger, we are having three users, Alice, Bob, and Carol, and everyone is having certain Bitcoin in their account. So this is a kind of a ledger which shows that how many users belongs to this particular ledger and what about the balances that they have. Okay, so now if I say that if there is a requirement to frame out a kind of a this is going to be a kind of a simple ledger. It is just like your passbook. Okay, so now how it is different from the smart contract. So as I have already told you in my previous sessions also that the smart contract is nothing but a kind of a programming that you are going to perform using this Solidity as a programming language, or using Python as a programming language, or using Node.js as a programming language. Language is not a barrier. Viper is also one of the language which you can use in order to write the smart contract. So I can say the smart contract is a tiny program that is written in some programming language. And on the top of that, we are running these programs on the top of the blockchain. That means in order to realize the actual impact of the smart contract, we need the blockchain. So we can say that smart contract is one of the segment of the blockchain, but on the top of that we need the blockchain. So it's going to be kind of a platform, and on the top of that we are using the user defined program, and these user defined program we can call it as a smart contract. Again, the scenario is same if we compare this slide with the next slide. So now here, instead of that, how these users are going to transfer the money with each other or to the external world. So in order to have this kind of ruling, or we need to fix up some kind of ruling, and this ruling is what? This is nothing but a kind of a contract. So that means how they are going to initiate, or how they are going to transfer the money to with each other or to some external sources. So for that particular purpose, we are just storing how much money user A is having, how much money user B is having, how much money user C is having. If I just take an example, all these informations are contained inside a code. Okay, and that code we can call it as a tiny program, and this tiny program we can call it as a smart contract. Okay, and yes, definitely we need to store this smart contract. So in order to store this smart contract, every individual user of any application is having the copy of the smart contract, this copy, this particular code, and we need to store it on the blockchain because it is going to be kind of a distributed ledger. So this is a very simple and abstract definition of smart contract. Now, how this smart contract is different from the normal contract, as I have already told you. Let's say what is the meaning of this dump contract or a traditional contract. So let's say, for example, I have given, let's say Alice has given certain amount of money to Bob. Okay, I'm just considering some example. Let's say Alice has given some money to Bob, X amount of money to Bob. Let's say we consider this $10 Bob will give to Alice. Okay, so now that at what time, instant of time, Alice is going to give this money back to the Bob, the deadline they need to fix. Hey Bob, hey Alice, I want to give you $10. I'm ready to give you $10, but you have to return this money back to me by this particular date. Okay, if you are not giving the money back on to this particular date, then you need to pay this much of fine per day. So this is what, these all are the negotiations, these all are the rules that Alice and Bob, the two parties, they have framed out. And after framing out the entire negotiation, entire rules, both the parties, if there are two parties like Alice and Bob, they have to sign it. And this is going to be a kind of a legalized document. And this document, we can call it as a traditional contract, or you can call it as a dump contract. So let's say, for example, let's say for whatever be the reason, after this particular date, Alice never returned the money back to the Bob. And after, let's say, 1 month, Bob again requested the Alice, please give my money back. Then denies, no, I do not want to give your money back. Then what option is left with the Bob? The option left with the Bob is Bob need to go to his or her lawyer and take the help of court in order to do this kind of settlement. Okay, so that's the way this third party comes into the picture if you want to execute the dump contract or the traditional contract. Now we will see that how this dump contract is to be replaced by the smart contract. So now this smart contract is similar to the physical world, but it is in the form of digital. What is the meaning of that particular line? It means that we, in the smart contract also, we need to frame out some kind of ruling, some kind of negotiations, but all these things we need to program. There is no requirement to note down all these things on a piece of paper or on a non-judiciary stamp paper. There is no requirement and get it notarized. Now this entire ruling and regulations, like let's say what is the date, how much amount he need to return back, and if not returning within a prescribed date, then what about the penalty imposed to the second party. So all these informations are contained inside the tiny program, and that tiny program is stored inside the blockchain. So this tiny program is what? This tiny program, we can call it as a smart contract. And this smart contract, which is a tiny program that is stored inside a blockchain, that contains what? That contains the rule of negotiation in terms of agreement. And let's say, for example, the Alice is not giving the money back to the Bob within this particular defined threshold or the time limit, maximum time limit, then rather than the Bob will approach to the court, here this tiny program, that means the smart contract itself executed, and the required money is debited from the account of the Alice and transferred back to the Bob. This is the beauty of the smart contract. That means this tiny program or the smart contract is automatically executed based upon what? Based upon the milestones and deliverables that you have fixed up, or over that all the parties are already given their consent that this is final. So based upon that, without any third party, this tiny program is automatically executed. This is the beauty of the smart contract, and this is the reason why nowadays companies are developing the smart contract between the client or multiple client, among the client or the different stakeholders. This is the reason why in today's world there is a more demand for the blockchain developer, particularly for writing the smart contract. Okay, now moving further, what are the example of smart contract? So I will tell you some of the slide I am just skipping because these are not for whatever is mentioned I have already discussed. So that's the way we will complete this theoretical stuff within 30 to 40 minutes, and I want to spend more time on this implementation part of the blockchain. Now, why there is a requirement? Why do we trust on smart contract? Why? Let's say I have written a tiny program smart contract between the which contains some kind of deliverable between the multiple party. So why should we trust? So the reason number one is because they are immutable. That means whenever you have frame out the smart contract, there is no flexibility available at the end of, let's say, in a network there are 50 users. All the 50 users are having the copy of the smart contract. Okay, let's say user number 32 has updated the copy of the smart contract, but doesn't make any sense. Why? Because rest of the members are having the always the updated copy of the smart contract. So that's the way we can say that they are immutable. That means unable to change. After the deployment of the smart contract, there is a very less scope available to do any kind of modification, and they are distributed. This is the reason number two. Why? Because whatsoever you are having the user in your network, all the users are having the copy of the smart contract. That's the way they are distributed. Now coming to the difference between the contract and the smart contract, I have already told you in a very simple way by considering the example of Alice and Bob. Now if you want to compare that how the traditional contract or the smart contract is different from the traditional contract, so the comparison parameter may vary. So there are a lot of other parameters are also there, but I have selected only few parameters. So the first comparison parameter according to which we can compare the traditional contract and the smart contract is the language. Normal contract or the traditional contract you have to written on a piece of paper or a judiciary stamp paper or NJS, non-judiciary stamp paper. Okay, that means you have to use some kind of legalized language in order to write the smart contract. Okay, but when it comes to writing the smart contract, then it is a piece of code, so that you can write. Lots of languages are available. You can write it in Python, you can write it in Viper, you can write it in J2 the Java, or you can write it in in any other like Go kind of language or Solidity language. This is the first difference. Second one is, let's say for example, who is going to be the identity or consent wise if I want to compare, then in the traditional smart contract, all the parties need to sign. Okay. But in case of smart contract, there is no requirement to do any kind of physical signature, but because blockchain is using the concept of digital signature, so that's the way we can say that digital signature we need to incorporate in the smart contract as far as the identity and consent are going to concern. Now, the third difference based upon the dispute resolution. In case of traditional contract, if any dispute will come, let's say I have given 50,000 rupees to Professor Hiral, and if let's say Professor Hiral is not giving the money back to me, then I have to report to the court, and because I have transferred the money to her account and this is the proof available with me, then the court will decide based upon the facts available or the proofs that I have submitted through my lawyer to the court. That means the third party is to be involved when you need to take the final decision when it is a traditional smart contract. But in case of smart contract, there is no involvement of the third party. So because they are executed without any involvement of the third party by their own. Payment wise, you need to carry out the parties separately. You need to give the payment fees, court fees, settlement fees, municipal stamp paper fees. But here it's a built-in fees. That means whatever services of a programming language or the deployment framework you are going to use, only that much amount of fees you need to pay. No need to pay the other amount of fees. Okay. So these are different comparison parameter, and I believe that this slide will give you the clear-cut idea that how the smart contract is different from the traditional contract. Okay. So now let's say, for example, couple of example I am just considering. All these I have discussed. The theoretical stuff is mentioned here. So what are the next question is, what are the potential Ethereum applications? So smart contract we can use in the case of tokens, in the case of lotteries, because a lot of in abroad, a lot of lottery companies, they have used the smart contract, because in case of lottery, you know it very well that how to establish the trust between the different individuals, because the mass is more. So how to establish the trust? That is the reason why this lottery business is using the Ethereum smart contract platform. Cryptocurrency exchange also uses, then marketplace, insurance heading, and supply chain management, or a sharing economy, and many more. This list is very long. I have selected only few applications. Those are using the Ethereum applications, or those are using the concept of smart contract. Okay. So now if you want to refer more, you can just Google it, the Ethereum applications, then you will find this particular link on the GitHub, where a lot of codes are also available, which will help you in order to understand the concept thoroughly. Okay. So now the next question comes. We know that what is smart contract, how it is different from the traditional contract. Now, what are the challenges associated for the development of the smart contract? So the challenge number one is where to write the smart contract. Like in the programming language, you need a compiler. Okay. Similarly, in case of smart contract writing, we need a compiler. So let's say, for example, if you want to write the smart contract in Solidity, then SOL is the compiler for the Solidity, SOL. Similarly, if you want to use other programming language, then you have to use the other compiler supported by that programming language. Now coming to the next challenges, this is the challenges with respect to the implementation. Now the other challenges for the development of the smart contract is their correctness and availability. What is the meaning of this correctness and availability? It is just like that I have developed the smart contract for my own application, and my application is related to healthcare. Is there any flexibility available to use the same smart contract for another application? There is a big no. You have to customize your smart contract. Okay, you have to rewrite your smart contract. So that is a big challenge. The standardization of the smart contract is a big challenge among the industry professionals, also among the research professionals also, that how to tackle this standardization problem of the smart contract. And you know that in case of blockchain is an expensive affair, not only expensive in terms of money, but sometimes in terms of consumption of resources also. So there are sometimes the uncertain delays, particularly in the case when you are using the public blockchain. So let's say I want to develop the smart contract for the public blockchain. And in my first lecture, we have discussed that in the public blockchain, anyone can join the network at any instant of time. So we don't know who are our neighbor and at what time stamp I am getting the data from my neighbor. I never know because it's an open environment. So that's the way. This is how to minimize this delay. Okay, this is also one of the challenge associated with the development of the smart contract, or some other challenges are also there, but these are the primary challenges which you need to take care while you are going to develop or design the smart contract. Now couple of slides I am going to just skip. Yeah, this slide is important for you because uh, let's say you are highly inclined towards writing the smart contract because you love programming. So now the next question comes that how many different types of programming languages are available on which or using which I can write the smart contract. So if you talk about, if you that, let's say for example, you love JavaScript and you know how to write a program in JavaScript, already you have the basic knowledge of JavaScript, then for you, Solidity is a most preferable language. So if I talk about in terms of the global perspective, so across the globe, more number of developers are using primarily the Solidity as their first preference to write the smart contract. The reason is very simple, because it is similar to, somehow similar to the JavaScript. That is the reason number one. Reason number two is a lot of 24/7 support is available in order to write the contract in the Solidity, and it is compatible with the Remix ID, which is going to be a kind of a open source platform for writing the smart contract. Okay, now let's say those who love Python, let's say any student is having knowledge about the Python, then for them Serpent is a language which you can use in order to write the smart contract, or Viper is an upcoming language. Not much support is available for the Viper developer, but yes, over a period of time, Viper, you can also use those who love Python as a programming language in order to write the smart contract. So this is about the contract, because whatever language you are going to use, ultimately, whether you are using the Serpent, Solidity, or Viper, or any other programming language, you need to convert the Ethereum virtual machine bytecode stack language. Why? Because the compiler of that particular can understand that particular bytecode only. It is just like that. If I compare it, whatever I am typing from my keyboard, let's say Ram is a good boy, RAMISAGOOD. The processor of my laptop never understands this ABCD. Against that, this is the internal process that whatever I am typing from my keyboard has to be converted into a language that is supported by the CPU or your processor, that we can, you know, everyone that we can call it as a machine language. Okay, so similar is the case here. Whatever language you are going to use, when it comes to the compiler, then bytecode is going to be generated, and your compiler will understand only the bytecode associated, and we will discuss it when we discuss the implementation of smart contract. Okay, now moving further, so now let's say for example, I am certain slide I am just skipping, and I will directly focus more on the implementation part. So like in the normal programming, in the normal programming, we are having the call by value, call by reference. Okay, so let's say I have created a user defined function, and it is up to me that how many number of times I want to call that particular function in a normal programming language. So same concept is applicable in case of the smart contract also, where let's say you have three different ABC construct, and under that particular construct, let's say for example, you have defined a function with the name call. Under that particular case, you have written certain statement, and this gas is what? This is a kind of a currency, virtual currency. Virtual currency means what? Let's say if you are deploying the smart contract on a platform, so what kind of amount is debited from your account? For what sense? Because you have used a particular platform. So here in this particular environment, we are not consuming the physical money, but we are consuming the virtual resources. So this gas, ethers, all these are the virtual currency basically, or virtual unit, or some test networks are available that you can use in order to understand the complete implementation of the blockchain technology. So whenever this let's say, for example, whenever I use this particular function with the name of call, my call is transferred to the location where it is defined. Now I have defined, let's say here. Now then next statements are going to be executed. Again, my control is transferred to the next location. And again, after that, it is going to be a kind of a sequencing that you know very well. So same concept you can also implement when you try to implement or when you have the flexibility to implement the smart contract for your own application, for your own definition. That means contract call stack is possible in the smart contract development also. Now certain slide I am just skipping. So this is a very basic layout of the smart contract. So this is like a hello world program in the C programming language. This Pragma Solidity is what? This is the, so Pragma is the compiler of Solidity. Okay, like we have a different compiler of C. This 0.4.19 indicate what? This indicate the version of this Pragma compiler, which is one of the compiler of the Solidity. Then this, all these word, those are having the blue color. All these are what? All these are the keywords. Like if I am using the GCC compiler, then you have also noticed that certain color are to be changed. Or if I am using other compiler also, the keywords, whatever the keywords are there in the programming language, those are converted into a specific color. So this contract, this is the contract, and then you have to specify the name of the contract. So let's say whatever the contract I am going to create, I have framed out the name, or I have given the name of the contract as test contract. Then I have to declare the storage, because once I have created an object of this class, and what is the name of my class? Name of my class is the test contract. Now I have defined a variable, let's say integer. My storage is a kind of a variable. Now the next is we need to define certain functions that you want to call. So test function is a function that you want to call, and under that particular function, whatever statement you want to write, flexibility is available. You can write that much statement. Okay, so this is a very simple hello world kind of program. And if you want to store this particular program, then by default, let's say test.sol. .sol is the extension of Solidity for this particular program if you are going to write it in the Solidity programming language. So this is a very dummy contract, basic dummy contract, just says test contract. And under that particular test contract, I have declared one storage, one variable. I have defined one function, and a lot of other scope is available for me to define certain, to perform certain functionalities under this particular function, or blah, blah, something like that. So we will discuss the more technical stuff related to the same, and then we will shift to the implementation part of this particular concept. Now, prior to that, let's say, for example, let me take a very simple use case, and through that particular use case, I will tell you that how the smart contract is different from the traditional contract, that you know it very well. Now I want to just show that how now in the couple of few slides, I'm going to consider a very simple use case, and through that particular use case, I will try to show you that if you want to apply the smart contract or blockchain, then what advantages you are going to get. And if you are not applying the smart contract or blockchain, then what is the entire use case is there. And then we will compare these two different with and without blockchain. Okay, I think that is going to be a good learning for all of you. So let's say first we are not going to discuss about the smart contract. So all of you heard about this crowdfunding platform? Crowdfunding platform, please write yes or no. Please write yes or no in the chat window. I believe that all of you have heard about this crowdfunding platform. There are nowadays a lot of crowdfunding platforms are available where you can donate some money. Yes, very good, Yogesh ji. So now let's say one of the crowdfunding platform I have considered here is a Kickstarter. A lot of other crowdfunding platforms are also there. Let me just consider the Kickstarter. So Kickstarter is the world largest funding platform for creating the project. So let's say, consider a very realistic situation in your class there are 4 students and they do not want to become entrepreneur, they do not want to start their own joint, they do not want to go for MS or MTech, they do not want to take any opportunity. Why? The reason is very simple, they want to become entrepreneur. So now what is the problem? The problem is they don't have single penny in their pocket. So believe me, if any individual is not having any single penny in their pocket and still they want to become entrepreneur, then what are the options available with them? The option is this third party crowdfunding platform will provide some kind of support to them. Okay. So now let's say, consider we are going to discuss this example, this use case step by step so that you understand the concept in a depth. So let's say you have an interesting project or the group of students are having interesting project, but they do not have sufficient money to execute the project, but they know the idea is very novel and technically they are very competent, but only thing they need money. Okay. So what they do, they just submit the project to a crowdfunding platform. Step number 2. So after submitting the project to the crowdfunding platform, in the crowdfunding platform, like if I take an example of Kickstarter, so whenever Kickstarter receive the proposal or the project from them, then Kickstarter will float this particular project to the different stakeholders. What are those different stakeholders? So you can call them as a financiers, basically, or supporters, basically. Why? Because they are ready to invest. They are ready to support your idea with some handsome amount of money, but at the same time, they are more worried to check what is the technical competence in your project or whether your project is feasible or not. Okay, it's something like that, or you can consider the other parameters also. So now, whenever the Kickstarter receive your project, then the same is broadcasted to the entire supporters. Like these are all are the supporters. Those are having fund that they want to sponsor. Now, the platform ensure that you get the complete money if the project is successful. That means in between the supporter and the development team, the third party is the Kickstarter. That means the supporter is relying on the Kickstarter, development team is also relying on the Kickstarter. And if I say that there is a big question mark on the integrity of the third party like this Kickstarter, so who is going to ensure the whether the money of the supporter is safe? Point number 1. Point number 2, if the project is executed successfully, then they have listed in the contract that they will get the 30% of the amount to their account. Then how will they ensure that they are getting the 30% of the amount, total amount, 30% of the total amount to their account from the supporters through the Kickstarter? So there are a couple of examples. So this is a very, in this particular example, we have not considered the blockchain. So this is without the blockchain. That means we are going to rely completely on this Kickstarter. Okay, because it is not end-to-end kind of communication between the developer and the supporter. Now, how this smart contract is going to be used, or in this particular case study, we have discussed without the blockchain. Okay, so now we are going to discuss with blockchain. So crowdfunding platform with blockchain. Nowadays, many crowdfunding platforms are there which are using using the centralized platform, they are using the decentralized platform. And the reason is very simple. Why? Because in order to develop the trust among the different stakeholders, the moment trust among the different stakeholders is established, then it is going to be a kind of a win-win situation. It is going to be good for their marketing and attracting more number of stakeholders towards their platform. So now we will see how this smart contract is going to play what kind of role in this particular use case. Without blockchain, we have already considered. So the contract, this is what the highlighted part here, this is the contract. And this contract is written between the team of students, 4 students, or you can call them as a product team, and the supporters. Those are ready to sponsor the idea of the product team or the group of 4 students. If we take our own example. So now this piece of code is written in Go or Solidity kind of language, and the copy of this particular contract or this code is available with all the stakeholders. Developer is also having the copy, product team is also having the copy. So, okay, so have you seen any application of blockchain here? Please write yes or no. Have you seen any application of blockchain here? Yes or no? See this example very carefully and then tell me that have you seen any application of blockchain here? Yes or no? The answer is yes. There is application of blockchain. Why? Because this contract never stored on a single platform. Every individual is having the copy of this smart contract. Okay. So now how this entire use case is executed. So let's say if the certain goal of the project is reached, what about the certain goal? Those are mentioned in the piece of code, or certain goal, like let's say for example, the goal number 1 is if the first module is completed, then the product team will get the 30% of the entire cost of the project to their account. Okay. So this is the goal number 1. Goal number 2 means if the module number 2 is completed, they will get again 20% remaining amount, 20% of the remaining account. Goal number 3, if the module number 3 is completed, they will again get 10% of the remaining amount. So this is what? This is the amount that is going to be credited to the account of the production team, but they do not need to submit the hard copy. What happened in the traditional scenario? The product team will have to submit a kind of a voucher, and this voucher will go to the account department will go to the audit, and then auditor will audit it, and then after the audit is successful, the amount will be credited to their account. But this is not the scenario in the blockchain by using the concept of the smart contract, because all the rulings and negotiations that on if the first module is completed, they will get the 30%. This is written already in the program. So we have programmed these goals inside this smart contract. And this is the beauty of the smart contract. Whenever on a particular threshold, let's say by 22nd of February, 22nd of February is the deadline for goal number 1. So automatically in the morning of 23rd of February, this goal is executed, and they are checking that whether what is the performance or progress of the project. Automatically the required amount, whatever mentioned in the goal, is credited from the account of the supporter to the product team. So that means if the goal is achieved, then the code means the smart contract automatically executed, and the required amount is transferred from the account of the supporter team to the product team. This is the good part. Now, what is the negative side, or what is the second side of this particular? Let's say, for example, because of any reason, if the goal number 1 is not achieved by 22nd of February, just I am taking one example, then what happens? What kind of penalty will be imposed? Then in that particular case, if the project goal or the contract fail, under what circumstances the contract fail? If the goal is not achieved within the deadline, then this smart contract code is executed by default without any human intervention, and the required fund is debited from the account of the product team and credited back to the supporter team. This is the beauty of the smart contract. That is the reason why nowadays companies are shifting to this, because it's a completely unbiased system. There is no biasness at all. You can give some kind of incentive, some kind of unfair means to the account department. Hey, you just favor me, please pass my bill, so and so, something like that. But here, if you make it a program, then there is less scope available to do any kind of cheating or any kind of fraud. That is the big advantage of why the people or the community, they are using the smart contract for building their smart applications. Now, moving further, now the advantages we have already discussed. Now the next question comes that what are the different smart contract development platforms are available. Now let's say you feel yourself motivated that I want to learn smart contract. Theoretically, I know. Now I want to code the smart contract. So what are the different platforms available to implement the smart contract for your application? So I will suggest the beginners that first you can use the Ethereum Remix ID. This is not going to, no installation is needed. It's an ID basically, Remix Ethereum ID. If you just write in the Google Remix Ethereum ID, The first link will appear, you just click over it, it will open the browser. Okay, so it will open a kind of a IDE basically. There is no installation is required, very lightweight tool basically. Okay, so I will suggest all of you please use this Ethereum. If you feel yourself more comfortable in Ethereum for writing the smart contract, then you can move to the Hyperledger, because certain functionalities of Hyperledger are not open source. For that you need to pay, you need to use the subscription model of Hyperledger. And Ripple, Rootstock, these all are the other platform which you can use in order to build up the smart contract. And not only these are the tools to develop the smart contract, a lot of other tools are also there like Ethereum, RSK, Ion, Tron, Stellar, Hyperledger Fabric, NAME, Cardano, Corda. This list is very long. So all these are what? All these are the platform which you can use in order to write the smart contract. Now, one takeaway for you people that I want to highlight here is, if there are numerous tools are available to write the smart contract, then sometimes it gives a kind of a confusion to us that which implement tool I should use and which implementation tool is to be given more priority to the rest of the available tool. Very genuine question. Now, there is no straightforward answer. You need to explore for which application you want to develop the smart contract. So let's say, for example, if you want to develop the smart contract for any financial application, then for the financial application, you know it very well that how sensitive is the data. Okay, so that means you are directly dealing with some kind of money, some kind of cryptocurrency or digital currency. That means you cannot go with a public kind of setting. You have to use a kind of a consortium based or a private blockchain. So that means it is dependent on the application, that what are the requirement of your applications, and then you have to do a direct mapping that these are the requirement of my application and these are the characteristics of the tool that I am going to use, or I am willing to use for writing the smart contract, and do a kind of a one-to-one mapping. Okay, so like some parametric comparison I have written, that language wise you can compare, because some students say that I love to code in C++, so forget about the rest of the language, rest of the execution platform, you can go with the EOS. Then some say that I love to write in C, I love to write in Java, a lot of scope is available. Or if you say that I love to code in Solidity, so means language can be one of the comparison parameter, or permission type, cryptocurrency, or application. So primarily these are the different platforms which you can use in order to write the smart contract. Now I will tell you in a very simple way that if you want to write the smart contract for your application, let me just skip some of the slide and directly come to that particular slide. So I have already told you that how many types of languages are there in order to write the smart contract, like Mutant. Mutant is a programming language which you can also use to write the smart contract, but it's a Go kind of language that was not available right now and not favorable among the community, and it is no longer used. But some people have already used the Mutant. Then the second one is the low-level language, like Lisp programming language, but this is also not very popular language among the community. Serpent is also one of the language which you can use in order to write the smart contract, like Python-based programming language, but not very friendly among the community. These two languages are more preferable among the community, as I've already told you, Solidity and Viper. If you love Python, then you can go with the Viper. If you love Java, then you can go with the Solidity. So these are the two best options as per my knowledge, that you can use Solidity or Viper as a programming language to write the smart contract. Now, what are the compiler? Why we need the compiler for writing the smart contract? Because whenever you are writing the smart contract, there is a requirement to convert the high level written contract to a more comfortable format, or the understandable format which your Ethereum execution platform can understand. That is the reason why the compiler is more important here. So Solidity compiler is SOLC. SOLC is the Solidity compiler, which convert your high level Solidity language written smart contract into Ethereum virtual machine, that is the EVM bytecode. Okay, so that it can be executed on the blockchain by Ethereum virtual machine bytecode. Otherwise, the environment is not going to understand that what you have written unless and until you are going to use the compiler for the conversion or to do this kind of conversion. Now, lot of other ID, I have already told you that Remix is an ID which you can use for writing the smart contract. And I'm also going to demonstrate the Remix in front of you. Okay, so if you just Google it, remix.ethereum.org, then this kind of platform will come to you. Okay, and in this particular platform, this is the place where you can write your smart contract, or this is the interface available for writing the smart contract. You can compile, you can run, you can do some kind of debugging, you can use some kind of analysis, and you can deploy your smart contract. You can execute your smart contract. Once you have executed your smart contract, then this Remix debugger will appear. So this various features, such as your on the top of the left hand side, the source code is written. So this is the source code where we have written our smart contract, and this is the output log basically. So this is the output log which shows certain information that this smart contract is written between who are the parties among which this smart contract is written, and what about the cost that we need to pay in order to write this particular smart contract. Okay, now certain more slides I am just keeping, and I will directly shift to the, just a minute, I will just shift to the code, and then after that we will see the implementation. Okay, so this is the example of a smart contract where it's a very simple smart contract, just an example, just for the demonstration purpose. As I have already told you that this is the Pragma is the Solidity compiler, and this is the version. Lot of various versions are available for the writing the smart contract, particularly with reference to the Solidity. After that, this is the contract name. So it is up to you that what kind of name you want to give to your contract. After that, in this particular smart contract, we have used some kind of mapping between what we have used some kind of balances. So it is a kind of a local state machine, a mapping from the user address to unsigned integer. Okay, so we are going to use in this particular smart contract some kind of unsigned integer, and I'm going to check the balance of each and every individual user. This is my intention. For that particular purpose, I am writing this smart contract. Now after that, I'm just defining a function here, and the name of the function is deposit. Okay, so deposit is the name of the function, and that function will allow the user to deposit ethers. So ether is what? Ether is also a kind of a currency that you can use like gas or ether at the Simple Bank contract. Simple Bank is the name of the contract. Okay, that means you have created a function with the name of deposit that allow the multiple user to deposit the ether. Okay, up deposit to which branch, deposit to which account. That means you need a kind of account number. So that's the way we are going to create another function. Function can receive the ether payable public. So we have made it public. It is up to you that in your application there is a requirement to make it public or the private. It is up to you or your application that for which you are writing the smart contract. Then after that, if you make it public, then any user can invoke this function, and anyone can be the part of this particular contract. But if you make it private, then you have given a kind of a restriction, right, that no one is having the flexibility to deposit certain amount of ether from which one account to another account, but only the restricted number of user can do or can perform this kind of functionality. Now after that, this MSG DOS sender is what? It will return the address of the transaction sender. So who are the transaction sender? So definitely, and after that, what kind of amount you want to transfer, and definitely after that, this amount is going to be referred and going to be refreshed after every transaction is completed, and then it will trigger a transfer of ether with a value equal to the balance message.sender, and that balance is inside that particular to the transaction sender, and this will set a kind of a, because you know the concept of garbage value, you know. So in case of garbage value, just to avoid it, we need to assign the 0. So we need to set the balance of the transaction sender to 0, and then it is going to be updated transaction by transaction. So this is a very simple demonstration of the smart contract, that how you need to write the smart contract. Now let me just open the platform, and we will directly discuss that how the smart contract look like. So I believe that my browser is visible to all of you. Anyone just please reply.
Sir, it is visible.
Perfect, thank you. So this is a Remix Ethereum ID basically. So let me just copy this URL to all of you. So I will just open, let's say if you are writing Remix IDE. Okay, so it will open the first link. Okay, and you just open that particular link, all of you. I'm just copying it. You will just practice with me so that you understand and create a kind of a bookmark of it. Okay, so I have just copied the URL of this particular ID to the chat box. Please copy it and make it as a bookmark, and please open it so that you can also do side by side. Okay, so now once you have opened this Remix ID, then you will get this kind of interface. This is the entire interface of Remix ID, which is divided into two different segments. So let me just close it first. So first segment is what? On the left hand side, you are having different functionalities over which once you write the smart contract, you can perform different kind of functionalities. This is the area which is available for you in order to write the smart contract. Okay, so now if I click over this particular file explorer, then it will open the different files that are already open here. Like in this particular Remix Ethereum ID, I have already written 4 smart contracts. One is having the name storage.sol, second is having the name owner.sol, ballot.sol, and test.sol. Let me just click on the test.sol. So now let me just increase the font size also so that you will get a clear understanding. Okay, so this is the this is the entire code of smart contract, very simple code of smart contract. Okay, but it is very difficult to teach all aspect of Solidity programming language, but Solidity, believe me, it is going to be just similar to the Java language. So Pragma Solidity, once you are writing this Pragma Solidity, then this Pragma is the compiler of Solidity, as I have already told you in my briefing also. This 0.60 is the latest compiler of the Solidity. Then after that, I want to just imagine a big integer counter that the whole world could share. So I am defining the contract, and the name of the contract I have given as a counter. So that means I am just going to create a smart contract for the counters, and the name of the smart contract is counter. Now what this counter is doing, this counter can be incremented or can be decremented. Very simple. I again repeat, I have just want to write the smart contract for just having a counter whose value can be incremented or can be decremented. So I have defined an unsigned integer variable with the name value. Then I have defined a function with the name initialize. Okay, then I have defined another variable x as an unsigned integer, and I want to use it as a public environment. Okay, so that means anyone can join the network or can perform this kind of functionality. Then after that, I am using the assignment operator and assigning this value x of unsigned integer to value, which is also an unsigned integer. After that, I have defined another function with the name of get, and this will return me the unsigned integer, and this will return me the value, whatever I have entered here, because whatever value of x you have entered, then against that you are getting the exactly the same. Now, over that particular value, let's say I want to do some kind of increment and decrement. So two more functions I have created here. One is the increment function, and second one is the decrement function. Okay, so here the value is incremented and here the value is decremented. This is a very simple smart contract. Now, once you have written the smart contract, how you can compile your smart contract like in the normal programming language. C में आपको program लिखना है, then you need to do the compilation before you are going to perform the actual running of the program. So same is the case here. Remember, in my briefing, I have already told you that if you are writing the smart contract, you can do the compilation of the smart contract, you can do the implementation, execution of the smart contract, but before the actual deployment, you can also do the vulnerability assessment of the smart contract. What is the meaning of the vulnerability assessment? Because whatever smart contract you have written, it is okay that your smart contract is executed, compiled 100% successfully, but what kind of bug your smart contract is having, that you need to identify. Why it is so important? Because once you have deployed the smart contract to your application, it will not give you the flexibility to modify it. So that's the way it is immutable in nature. There is no scope, very less scope is available to do any kind of modification. Okay, so now let's say we want to compile this smart contract. So you can go to this particular left hand side Solidity compiler. If you can see my cursor, or after the file explorer, there is a tab with the name of Solidity compiler. I believe that all of you are working with me. Let me just all of you are working with me. Let me just copy this also, and let me check it whether it copied or not, so that you also open it. Yeah, I have copied this entire code. All of you please check. I have copied this entire code. So please copy this entire code to your interface also, so that in parallel you can also do this kind of exercise. Then only it is going to be a kind of a good learning for all of you. Otherwise, theoretically understanding the concept after attending such workshop, after 1 week or 2 weeks it goes. You never understand the concept unless and until you do it in a practical aspect. Okay. So I believe that all of you have opened. Let me write in the step 1. Step 1 is, if you have opened this particular remix.ethereum.org platform, please write one in the chat box. Let me check how many of you have opened this platform. I again repeat, if all of you have opened this remix.ethereum.org platform, please write one in the chat box. Let me check how many of you are attentive. Only 2% have written one. And how many individuals we are having? More than 40. Please write one. If you have opened this remix.ethereum.org, please write one. Very good. So I believe that 7-8 participants have opened this. Now write 2 if you have copied this code, whatever I have copied in the chat box to your compiler of Remix. Please write 2. Very good. Please write 2 if you have copied this entire code in the Remix platform. Only 2 have copied it. Please write 2. I am looking for more 2 in the chat box. Then only I will proceed.
ધ્યાન આપે ને તો બહુ મસ્ત હતું, પણ હવે કાઈ થયું નહીં.
Please mute yourself, all the participants. Yeah, what happened to the rest? They have not copied it. Please write 2. So once you have copied it, then after that you need to just go to this particular button. Okay, this particular button, that is, if you see my cursor, that is the Solidity compiler. So if you go to the Solidity compiler, then this window will appear, or this interface will appear. So how many of you have received this interface? Please write 3. Once you have compiled on this particular. Very good, Yogesh ji. Very good. So if you have received this particular interface, then after that you just click on compile test.sol. Press on compile button. So that means it is compiled. If you have compiled it, please write 4. If you have compiled it, please write 4. So after compilation, it will give you what? It will give you some kind of warnings only. If it will not give you any kind of error, then you can proceed. That means your compilation is successful. Now, what is the next step? Next step is we need to execute it. So now just after the compilation, you are having deploy and run transaction. Just click on deploy and run. Okay. So once you click on deploy and run, please click on deploy and run this particular button. Once you click on deploy and run transaction, then it will give you some kind of flexibility. Now listen it very carefully. Listen it very carefully. Java Virtual Machine, Berlin, Injected Web3 Provider. All these are the different platforms available to you. Let's say, for example, I want that my application is to be hosted on the web. My application is to be hosted on the web, and for the same, I am writing the smart contract. Then you can use the injected Web3. I will tell you, I am using it in the couple of moments. Okay. Apart from that, you are using virtual machine, virtual JavaScript, virtual machine London by default. Okay. This is the amount that you want to initiate. It is up to you that how much you want to initiate. By default, this is the gas limit. What is this gas limit? Gas limit is what? Gas limit is the, you can increase or decrease it. Let's say I want to insert one more 0. It is the virtual currency that for writing this smart contract, how much amount of gas you are going to consume out of the limit of the gas available with you. This WEIY is what? It is the smallest currency, smallest unit of currency available under this Ethereum platform. Then you can see counter contract ka name aayega yahan pe na, you can see it very carefully. Counter is the name of the contract which we have created, and 4.test.sol is the name contract under 4.test.sol. After that, you can click, once you have opened this, then you click on deploy. Okay. So once you click on deploy, then how many of you have clicked on deploy? How many of you have clicked on deploy? Please write 5. Those who have deployed it, please write 5. If once you click on deploy, then you can see it is creation of contract pending. It shows you that creation of contract is pending. That means your contract that you have created is pending. So only 2 things you can perform. One is the store and second one is the retrieve. Okay. So let's say if I click 2 functions I have created, na, store and retrieve. So that means whatever function, whatever you are typing here, let me just close it and let me just open it again. So let me do it again. So let's say if I open it, I will repeat the step. Then after that, you are just click on this. You just need to click on the compile. So once you click on the compile, then your compilation will be over. And once your compilation will be over, then after that, what you need to do? You need to do what? You need to just press on the deploy on this particular execution platform. And here you can see Rinkeby network is selected. Why the Rinkeby network is selected? So because I have used some test network, because this blockchain will give you some kind of facility of using the test network. It is just like that. If I need a money, as a bank, I need to go to the RBI. Similarly, if I want to use the virtual currency, from where I get the virtual currency? So this blockchain developer, they have created some kind of test network like Goerli, Rinkeby, Faucet. Okay, so these are represented as a test network from where currency chest, from where you can get some kind of ethers in order to perform your execution. Okay, so after that, if I am just deploying it, then it will create a kind of it will create a kind of a platform. And let's say if I select the, just a minute. So let's say if I select this, let's say the second I am just taking the second smart contract, that is the Solidity storage storage.sol. Same step I am going to repeat, and we will discuss that for what purpose we are creating it at the later stage. So let me first compile it. So once I compile it, then it will take some time to compile it. Then after compilation, the tick mark will appear here. Unless and until the tick mark will appear here, you cannot claim at what instant of time you are saying that that this tick mark, your compilation is okay. So please tell me how many of you are getting this tick mark on your compilation. Please write 6 if you are getting this tick mark, green tick mark on your compilation button. Please write 6. Please write 6 if you are getting this compilation button, this tick mark, green tick mark on the compilation button. Please write 6. So once you are getting this compilation button tick mark green, then you need to go to not yet green tick mark. So we need to check it because maybe some kind of issue will be there, so that we will resolve it. No need to worry. You just understand the concept first. Once we are getting this green tick mark, okay, after that we need to go to the compilation. After that we need to go to the deploy and run. Then I need to just press this deploy button, and once I press this deploy button, then after that what happens, the smart contract that I have created, all these contracts are going to be created, okay, and this will tell me a kind of a platform. Like, let's say for example, if I want to use, then it will not give me a kind of a flexibility to open it. So you can use any like third smart contract. For the third smart contract, if I want to check it, then if I want to use the owner.sol, so let me just close it. And after that, this is going to be a kind of a little smart contract. In this particular smart contract, we have used the contract with the name of owner, okay, and I have created an address, the private owner, and after that I am setting an event, and I am checking it whether the contract deployed by the owner or not. If the contract is not deployed by the owner, then it will identify if the contract is developed by the owner, then it will tell me the address, name, and certain other detail of the owner also. Otherwise it will give me a kind of a message that this is not to be entered by the owner. So this is a very basic smart contract. So now let's say for example, if I want to just compile it, so this will give me a kind of a flexibility to compile it, and after compilation of it, then I need to go to the deploy. Then here, let's say for example, if I want to deploy it, then it will give me a flexibility that what kind of deployment will be coming here, okay. So this is about the remix ID, that because sometimes the development of the smart contract will take more time, and after that I will show you that how your cost of that deployed smart contract will be debited from the MetaMask, okay. So let's say all of you just do this thing with me. So all of you just write MetaMask. Let me just share this particular with all of you. Let me just open your account in the MetaMask so that you will get some kind of test ethers. So all of you check your check this chat box. In the chat box, I have sent one URL with all of you, MetaMask. So MetaMask is what? It's a kind of a crypto wallet basically. Why? Because if we are writing the smart contract, then definitely some kind of cost is going to be debited from my account. That means what kind of cost? Here in the development of smart contract, these are the test basically smart contract, okay. So from where I am getting the money? So in order to get the money, you have to open the MetaMask wallet. So this MetaMask wallet, you can consider it as a currency chest, okay, which is belonging to you individually, and it is having a unique ID basically. So after opening this particular, you can download this MetaMask and associate this MetaMask into your browser, Chrome browser, okay. So note down this step basically. Yeah, you have to download it. After that, because I have already downloaded, there is no requirement for me to download it. Otherwise, all of you just click on this particular download it. So after downloading it, then you need to follow certain steps. That what are the steps? Steps are like that: how to associate or how to link your MetaMask with your Chrome browser. Okay. Once you link your MetaMask with your Chrome browser, then it will give you this kind of interface. Okay, you have to set certain account password and certain other steps you need to do. Or after doing these steps, this is your MetaMask account, and in this MetaMask account, this is your network ID basically. So now, after getting this network ID, what you need to do, you need to just press on this buy button. Okay, and after pressing on this buy button, you need to just press on this test faucet. Test faucet basically. Test faucet is what? And over that, you need to select that these are what: Ethereum mainnet, Repston, Kavan, Rinkeby, Goerli, localhost. All these are what? All these are the test network available to you to get the ethers just for your demonstration purpose. Okay, like you can see in my account, some people have already transferred on 16th of February, and this is my account. From this particular account, 18.75 ethers. Okay, so now 18.75 ether is available in my account. Same is the money I can buy, I can send, I can transfer, I can receive. So let's say I have selected here the Rinkeby network by default. And after the Rinkeby network, what I need to do, I need to just click on the buy. After clicking on this buy, then I need to click on get ether, because I need some kind of test ethers in my account in order to initiate certain transaction. Once you click on test ether, it will give you this kind of platform. Okay. So now sometime this is the entire layout of the Rinkeby test network, that how many blocks are already, it's a real-time environment basically. Looking at this particular environment, you can visualize that how many transactions are already committed, and you can see after every second it is going to update it dynamically. Okay, so now after opening this, you need to open another URL. I will just copy this also, because now you need some kind of money. So you just make this as also bookmark, faucet.rinkeby. So after that, what you need to do, you need to just click on this particular tweet. Okay, and after clicking on the tweet, but prior to that, you just need to open your MetaMask account. Okay, so once you have opened your MetaMask account, you need to copy your MetaMask address. Why this MetaMask address is so important? Because whenever the test network will transfer the amount to your account, definitely it need a kind of account. Like I want to transfer 50,000 from my account to another account, so I need that another account number. So for that particular purpose, I have copied my account number, and once I click on the tweet, I just replace this 00 with my MetaMask address and tweet this particular. Okay, and it said that you have already done it, because if you are doing it single day, it will not allow you to retweet again, because on the 16th of February at 12:10 p.m. I have already initiated this particular transaction, and I have already initiated 18.25 ethers will be transferred to my account, and you have already seen my MetaMask account that this entry is already reflected. But I will tell you the step. Once you click on this particular tweet, then it will show you some kind of interface, and after that you just need to click on what? You just need to click on the retweet and copy it, and after that you just need to copy that particular address here, and after clicking here, you need to test this particular network, that how many ethers you are requiring. Like in my case, I have already taken from this particular Rinkeby test network 18.75 ethers. So after third day, I am entitled to get again. Okay, so let's say if you are initiated for, it is up to you how many ethers you require. You require 3 ethers, 7.5 ether, or 18.7 ether. So After you click it, it will complete your transaction, and the same is going to be reflected in your MetaMask account. So this is the way how this why this MetaMask opening of the account is so important, because whenever you are deploying your smart contract using the Web3 injected Web3 interface, then it will give you some kind of flexibility for, let me just close it and let me just open it, just a minute. Yeah, you can see it now. Now you can see it very carefully. I have already told you that once if you press on the deployment, then it will give you some kind of characteristic, some kind of feature that I want to show you here. Once you click on the deployment, because we have created this smart contract for just a kind of a increment or decrement, and once I click on this particular green tick mark, then it will open certain other functionality to me. Okay, so what are the other functionality? Let me check it and let me show it to you. That it will give me some kind of functionality like what is the status of the transaction, success, this transaction, this is the transaction hash. Okay, and this transaction is between whom to whom, this is the address of the initiator of the transaction, kahan se start hui, and then what is the name of my contract? Name of my contract is counter, and how much gas is consumed in order to write this particular smart contract. So the same is going to be reflected here. And what is the transaction cost of writing this smart contract? So a lot of feature it will provide you to just see that, to visualize that if I am writing the smart contract, then what kind of the input is going to be taken care. And let's say, for example, now in the second task, I want to make a kind of a interface or alignment between the MetaMask and the Ethereum Remix. So here in the environment, if you want to do it, you can just select your injected Web3. And once you are selecting the injected Web3, then it will give you the flexibility that it is going to align with your MetaMask. So I will tell you a lot of flexibility available for you people to contribute in this area of blockchain, particularly in the area of smart contract development. So now it is all that I want to convey with all of you. Now we will take certain question answers. Now we will take certain question answers. If you people are having certain question answer related to the discussion we have made, I will just summarize what we have discussed. We have discussed about how the smart contract is different from the traditional contract, number one. Number two, we have discussed that why the Solidity is more, what are the different languages that you are going to use for writing your smart contract. Number three, what are the different platforms available to write your smart contract. And we have seen a very detailed implementation of 3 to 4 code related to the smart contract. Okay, and one of the sample I have already shared with all of you, that complete cycle if you want to do, you can write smart contract, you can compile it, you can deploy it. After deploying it, you can inline it with your application, and then with your application, it is going to be a kind of a matching, that whatever transaction you are going to perform here, the same is going to be reflected in your MetaMask account also. Okay, so this is a complete setup basically. So some of the part we have discussed. Okay, not the entire part we have discussed about the entire framework, because it will take another 1 to 2 hours to complete this particular implementation stuff where you are going to develop. Otherwise, you develop your decentralized applications and write smart contract for your decentralized application, and then with your application and your smart contract, try to inline both with the MetaMask. Okay, so now this is all from my side that I want to convey with all of you. Now we will take some question answer. If you people are having some question answer specifically related to smart contract or related to other two sessions that we have already conducted, day 1 and day 2. Yeah, over to you. Yeah, organizers, over to you.
Yes, sir. Thank you very much, sir.
If any one of you have any specific question, then please write in the chat window, or you can directly unmute yourself, or you can ask directly.
Any
I believe,
participants
yeah,
have any doubt?
any one of you have any doubt, please write in the chat window. Private method in the Yogesh, private method means what? Let's say if you are writing the smart contract, then definitely you have to identify that the application is require any kind of you want to give the access to all, number one. Number two, you want to give some kind of restrictions. According to that, if you remember in the last session also we have discussed that how you are going to decide that whether the private block is the right candidate for you or the public blockchain is the right candidate for you. So it is something like that. For whatever application you want to develop the smart contract, it is dependent on the application specific nature or the requirement, whether the public method is suitable or the private method is suitable. I will tell you one example. Let's say if I'm dealing with government services like midday meal, then definitely for that particular application, if I'm writing the smart contract, I can write a public kind of setting because it doesn't involve any kind of finances or any kind of harm to select any public network. But definitely if I'm dealing with some kind of financial aspect, then I can go with the private kind of setting. Okay. So any one of you have any question, then you can write in the chat window or you can unmute yourself, ask directly. Otherwise, this session is end from my side. So once again, thank you very much, all of you, and have a nice day. And I believe that this FDP is going to be a great learning for all of you, and you enjoying all the sessions, and start working in the area of blockchain technology, where a lot of scope is available for you people to contribute. Okay. So thank you very much, all of you. If you don't have any question, and keep the pace of learning high. Thank you very much, all of you, and thanks to the organizer. Okay. Yeah, have a good day.
Thank you, sir. We are very grateful that the practical session you had arranged for us is quite meaningful and very helpful to us to learn the Solidity and the MetaMask. Thank you, sir.
Okay, have a good day. Yeah.
The link of the quiz will be given in the WhatsApp. Kindly do participate